Did you know that a car hitting a wall at 40 miles per hour hits with the same force as if it fell off a 5-story building? It's not easy getting through the teenagers today. So at Liberty Mutual, we produce a video especially for teens about car safety because we'll do whatever it takes to keep them safe on the road. Liberty Mutual, it's more than insurance. It's insurance in action. Now for 50 miles per hour.
Okay, guys, given the fact that this is a commercial, what are the chances that the physics is accurate? The reason why I'm asking that question is a lot of the times on commercial TV, the science is not very accurate. It's getting better. I love the Science Channel. They're doing a much better job. If you really want to get some good science, just go to NOVA. Public TV does the best job. BBC is amazing. Okay, commercial TV, not so much. So given the fact that the commercial, so what are the chances that
the science is good? Did you know that a car hitting a wall at 40 miles per hour hits with the same force as if it fell off a 5-story building? Did a car hitting a wall at 40 miles per hour hits with the same force as if it fell off a 5-story building? Did a car hitting
All right, so that's the statement that we will check. We will try to verify. So a car falling from the 5-story building is going to hit the ground or will it at 40 miles per hour. That's what it is. So this is problem number 17, which requires a bit of a verification. So she claims that the car falling from a 5-story building is going to hit the ground at 40 miles per hour. So let's check to see if it's true, right? A 5-story building is roughly about 50 feet, so that's what we're going to use. So let's figure out the impact speed of this object. So initial speed is going to be 0. Distance falling is going to be 50 feet. G roughly about 10. Figure out the speed and then express it in terms of miles per hour. Right, so we listed everything. Now we need to do convergence. In terms of convergence, speed needs to be expressed in terms of meters. So we did the conversion by multiplying it by a conversion factor, so that's the number that we got. So the next step is which formula to pick. All right, boom, boom, boom. So just look at the symbols, the best formula based on the symbols. Notice that the only one that you can use, it just managed to the side because Zoom ended up changing their parameters, so it was not supposed to record people on the side, but it did. Okay, which means that you have to use the third formula for that one. Okay, now you can see it. All right, so the symbols, the third formula. All right, so if you have any zeros, plug in the zeros. The initial speed is 0, so this term is going to drop. If you have the square, by taking the square root of both sides. There's plus and minus, just assume that it's plus for the time being. All right, so now putting the numbers in. It's going to be roughly about 10. So we end up putting a number, and in terms of meters per second, converted to miles per hour, it's going to be 39 miles per hour, right? So what does it mean? It's pretty close to 40, approximately. Not bad. Commercial is fairly accurate in that sense. Okay, I'm actually impressed. Okay, now let's go back. Having worked at an art school, commercial art school, for roughly about 20 years, I can tell you that there's a lot wrong with this commercial. Just because you get the numbers right doesn't mean that it's accurate. All right, art students have to submit projects. 10% of their final grades came from these creative projects. And then you got to remember, I had these film students who are working as directors today. 1 or 2 of them are working for Disney, for example. There are a lot of commercial art students in terms of game arts and all that stuff. So they needed physics for that sort of stuff. Okay. Now, the evaluation of a project like this will go like
Did you know?
Following. Number 1, she looks like she could be a high school physics teacher. So acting is phenomenal. I'm looking at the students' complete apathy. That's normal because it's physics.
40 miles per hour.
This guy is carefully selected. Look at the face. You can tell that he's high on something legal or illegal. He's not really connected to what's going on. And then something weird happens. The representation of reality starts to fail. It starts to go to hell, in essence. She is pushing a car off the building backward. Is this the way it would be done? Absolutely not. I can see that she can push her car easily. Look at the leg. She's very strong. Like, the problem with the way she's pushing the car is it's backwards. If the car goes off the building, she can also potentially go off the building.
It's not easy getting.
Then it starts to get worse. If you can somehow push a car off a building like that, it's not going to go down straight down like that. It's going to start to rotate slowly. All right, so the rotation is missing. And then it still gets worse. Notice that there was a flash of light just before impact. It should never happen. And then there's a flash of light again. Special effects artists. Special effects artists completely got it wrong. At 40 miles per hour, there's not supposed to be a flash, unless something is terribly wrong with the car. There were 2 flashes of light.
So Liberty Mutual, we produce a video, especially for teens, about car safety, because we'll do whatever it takes.
So this was the only drop that they had.
Keep them safe on the road.
Using a crane, and that's it.
Now for 50 miles per hour.
So the numbers are accurate. The representation of reality, the real physics is lacking. That would be a C project. Artistically, it's really well done. There's always 4 seconds.
Did you know that a
changing scene, the angles are changing.
40 miles
Artistically, it's well done. All right, this would be more like a B project overall. All right, so that's what happens when I'm watching movies. You see all these details, and after a while, it gets to be distracting. Okay, very good. Neglecting the effects of air friction. everything is going to fall at the same rate. One drop, everything is going to be falling at the same speed. So he's the best answer you give yourself 5 points for that one. All right, so you drop a ball, throw a ball in the downward direction, and you throw a ball in the upward direction. All right, so which ball is going to have the greatest acceleration? If you throw a ball in the upward direction and the downward direction with identical speeds, which one is going to have the largest impact speed? What's the acceleration of the ball when it reaches its peak point in motion? What's the acceleration of the ball while you're throwing it? Okay, let's do quick demonstrations for these ones. Okay. All right, guys, which ball has a larger acceleration, this one or this one? Okay, all right, just hold on to your answers. You will get to self-evaluate. If you're right, you will get to add 5 points to your participation. And obviously, if you're wrong, nothing. Okay, so which one is a larger acceleration, this one or this one? This one or this one? I drop the ball, I throw the ball in the downward direction. I drop the ball, I throw the ball in the downward direction. So which one is a larger acceleration? So that's one of the questions. The next one is, I'm going to throw the ball in the downward direction and in the upward direction with identical speeds. If this is 20 miles per hour, this is 20 miles per hour. Okay, so up 20 miles per hour, down 20 miles per hour. So which ball is going to hit the ground at a larger speed? Which one is going to have a larger impact speed? Which one is going to have a larger free fall speed? That's what it means. The third question is, notice that when I throw the ball up, it comes to a stop at some point. So it's going to go up, it stops. At the moment the ball stops, what's the acceleration? It's either 0 or it's not. Those are the decisions. And also, while I'm throwing the ball, while I'm still in contact with the ball, what is the acceleration of that ball? Is it bigger, the same, or smaller than the gravitational acceleration? So those are the questions we will try to answer. Okay, so remember what it is that you guys are thinking, and then you will have to evaluate yourselves on that. Okay, so I drop a ball, and so I'm going to follow the ball for 3 seconds, and notice that the ball is going to be speeding up in that direction. That's the reason why the distance is increasing per second time interval. And gravity is the only force acting, and gravity makes things speed up at a rate of 10 meters per second each and every single second. So acceleration due to gravity is going to be 10 meters per second squared. What that means is this ball is going to go when dropped from 0 to 10 within the first second, and 10 to 20 within the next second. That's it. All right, so acceleration is going to be, when you go from 0 to 10 in a single second, it's going to be 10. When you go from 10 to 20 in the next second, it's still going to be 10. So that when the ball is dropped, the acceleration of the ball is going to be 10 meters per second each and every single second. So which means that it's going to keep gaining speed at a rate of 10 meters per second each and every single second. So next case is what would happen if you were to throw the ball in the downward direction, right? So that's what we're going to be looking at. So I'll throw the ball in the downward direction. That's 20 meters per second, guys. That's like 45 miles per hour. All right, so you just chuck the ball in the downward direction at 45 miles per hour. So that's 20 meters per second. So what happens as soon as the ball leaves your hand, gravity takes over, right? So what will the gravity do? Gravity says here, I'm going to make you go faster at a rate of 10 meters per second each and every single second. What that means is within the next second, this ball is going to be moving at 30 meters per second. Got it? It's going to be moving at 30 meters per second. So you drop it, it goes from 0 to 10, the acceleration is 10. When you throw it, it goes from 20 to 30, the acceleration is still 10. All right, this one is falling faster, but this one is not falling as fast. They're still accelerating at the same rate. So what's the difference between this and that? No initial speed here. There's an initial speed there. So the difference between this and that is this doesn't have an initial speed, this does. Once the ball leaves my hand, it's always going to speed up at a constant rate. That's what it means. So which one is a larger acceleration? This one or this one? Both of them are the same. All right, so that question is settled. Now let's move on to the next one. All right, case number 1 is done. Move on to case number 2. This time, what I'm going to do is I'm going to throw a ball in the upward direction and in the downward direction with identical speeds. Okay. Throw this ball in the downward direction and follow for 1 single second. So it's going to, and then I will place the ground right there. So it's going to, gravity is going to take over. So which means that this ball is going to go from 20 to 30 within the next second. And then I will throw this ball in the upward direction. Guys, acceleration has direction, right? The gravitational acceleration is in the downward direction. So if you go up against gravity, you will slow down at this constant rate. If you're moving in the direction of gravity, you will speed up at this constant rate. That's what it means. So thrown up against gravity, you will slow down. So within 1 single second, we'll go from 20 to 10. Within the next second, you will go from 10 to 0. What goes up must come down. So within the next second, we'll come down at 10 meters per second. Next second, it's going to be 20. Let it drop 1 more second. It's going to be 30 meters per second. This is 30, so is this one. All right, the only difference between this motion on this side and that motion is this takes 1 second. This is going to take 1, 2, 3, 4, 5 seconds. The end result is going to be the same. All right, so both balls are going to have the same speed, same impact speed, same final free fall speed. All right, so the next question is, okay, move forward. Notice that the ball comes to a stop at this point, right? So the question is, in fact, the ball is not moving at this point. Does it have an acceleration? Most of you guys will say no. If you say no, you're missing the point. Acceleration means change in velocity, guys. All right, is the ball moving before it stops? If the answer is yes, it's accelerating. Is it moving right after it stops? If the answer is yes, it's still accelerating. It's not like a bus stop. You don't come to a stop and stay there. It's part of motion. It goes up and comes back down. All right, it doesn't stay there. If it's moving before or after, it's always accelerating. In fact, about a second before it stops, it's going at 10 meters per second, so it goes from 10 to 0, so the acceleration is 10. And then it goes from 0 to 10, so the acceleration is still 10. Got it? In fact, once the ball leaves your hand, acceleration remains constant, it's going to be g. It's going to be 10, roughly about 10 meters per second squared. Why? Because that's when the gravity takes over. All right. You kind of need an answer because I gave you the answer in the beginning of the lecture. Now you understand it because the understanding was missing. All right. Once the ball leaves your hand, the acceleration is going to be constant. Gravity takes over, and if you're going up against gravity, you will slow down at a constant rate. If you're moving in the direction of gravity, you will speed up at a constant rate. All right, so which one is not an example of free fall? The one which is not an example of free fall is the person actually being in control of the ball, right? If the person is in contact with the ball while the ball is in the process of being thrown, that's not free fall, which means that the acceleration could be larger than 10, smaller than 10. It could be the same as 10, but that's not gravity. So that's not motion under the influence of gravity. So those of you guys who put D, yours has 5 points for that one. So at the peak of its trajectory, when you throw a ball in the opposite direction, right there, it's not moving. So the velocity at that point is going to be 0. Put that 5 points for that one. Okay, so let's